Save the answer somewhere, just so we can compare. Marker plot is not defined. Where's the plot here? No, this is wrong. What did I do wrong? Append. It's the other way around, and it's like super close. Sigma sample size index, but this is the thing, right? Let's see. I believe the first exercise I'm already wrong. I cannot really pull this. Oh my god. No, where this? It's completely different. There's no way. Something has to be wrong. Minus these IF form. Pent not should be fine. Value. Maybe something change. Collab. Yeah, it's -5. Did it change it? Hochladen. Could be actually. A ver, let's see. Linear model. Model is basically theta 0, theta 1. Where's x? What's x? X is up there, right? Okay, yeah, of course. Lambda that. Create a lambda. So implements a cost function. This is the cost function. We have the model here, which is basically that. No, the model is that right? Yeah, exactly. So it's basically doing n equals to len of x, and then the multiplication is we first have to get the sum of everything. So sum is equal to a number. We can call 0 the moment, and we do for x. I can just go for the I anyways. For loops Python. Or is the guy that showed me? I said it in favorites, right? Anyway, let's continue. Lists flow loops here for index in range n. So we do that, and then we do the model. So we have to calculate the model, which is basically we have it here, the linear model. So we calculate model calculate, what do we do? XE? No. What do we call it? Model res. Model X. Needs theta 1 and theta 0. But of course, this will return the function. So this is a function lambda. So cost def basically this. We can even call it J. It's better to get a real value. Then here, theta 1 and theta 0. Then we move this. We do this linear model theta 0, theta 1. Oh wait, there's never, I implemented it. What? Why is it not saved? I'm implemented in the wrong place. Implemented here. It's basically here. Theta 0, theta 1. Linear model basically receives model. We get here model equals linear model, and then we get here xe equals linear model from x, because x is, let me look what it first. Yeah, it's just x. So x, and then I need the index of xe, and then sum equals plus equals. Then we have the x, it's not really the xe, right? But the model result minus ye, which is basically this index, the rest. And then at the end we do return, and then is this, yeah, yeah, the sum is to do numpy or math dot, did I import math at some point? Import math as math Python math power of 2. I can also do this, right? But math pow. Cool. And then we do math dot pow to the power of 2. Put math. We have run this before. To the power of 2. At the end, result is equals to undivided by 2 times n divided by 2 n times sum and then return res. Check if the function is well implemented. Don't change anything, which is let me know. Let's see. There's a small logic error. Handler is called within the loop. You find a model which creates a function. Yes. How in the next line you're calling? Yeah. That's the mistake. It's model. It's model Yeah. Should it correct right? Let's see, let's keep this answer. Let's compare it here. On this type error, non-type is not callable. Y is equal to maybe correct, right? Yes, it's correct. An object is not callable. Why? Because, yeah, because I have to return the return. I don't know why. Yeah, it didn't tell me there was a mistake. Cost func. Right here. It should work. Cost function. Why? Non-type and float. Why is it complaining about it? Operates, but I'm using them here. Yeah, non-type and float. Model res model. This is a mistake. Func. Why say I'm not catching this? They're very different results. They're really different results. 277. Check all of the exercises so far. Are they correct? Don't change. Just check. Yes, really so far they're completely correctly implemented. Things about like, let's see.
M.
Hello. I tried for real, for real. How are you? Welcome to the stream. I want to create a plot for the model on the data, in which we show the data as a scatter plot. As a line, indicate the current cost, print statement. We change to that one.
M.
Sure, give me the thought experiment. Ooh.
M.
Data points marker X, still data points.
M.
So I'm getting teleported into a country I don't speak the language of in 24 hours. What are some of phrase words I need to memorize to survive in said country? Trying to find the least amount but useful words and phrases. I think the problem is depending what you're gonna do in the country. Are you being thrown, like, do you have a house? It's like more of a jungle from there. You don't have anything. Do you have something? You just get teleported without anything.
M.
Do you have money with you? But do you want to do in the city? You can explore. If you want to explore, do you get teleported back?
M.
They have USD. Do you get teleported back after 24 hours, or you just like stay in that city? In that city.
M.
Oh, you don't. So you must research to find a way back home. And then I'll just memorize. If I know I'm gonna get teleported in that place and I have to get back home, I will just memorize sentences like "Where is the U.S. embassy" or something, and maybe memorize because they'll tell you directions. So memorize like straight, left, right. Maybe the words for turn. Maybe like the words in front, behind, all of that. So you can navigate, and then I would ask people where's the U.S. embassy, and then when I go back to the U.S. embassy, then I get back to the U.S. I mean, if I'm from the U.S.
M.
Yeah, no problem. Anytime. Let's do this. And the plots. So let's keep it. Create plus grid, interval one sample. So let's see. For zeros, that one t0 partial derivative for array of values. Partial derivative for theta 0, partial derivative for theta 1. Okay, this is just basically this. Maybe I move this a bit here. Let's see. Partial derivative of theta rho is equals to we first need the sum, so it would be an r is function, so we don't have that. Maybe what I'll do is write this down, but later. Let's go with this. Oh. Well, equals to which is this. Uh, I need my coffee. I'm still very sleepy. Residuals. We need the residuals for each one. So we could do like def residual equals or residual, and then it is basically it's too many. I think the best thing is to do the whole thing in one go. Or maybe we can do it just step by step. So the step one is the prediction. So we do prediction equal to no, but too much work if I do it that way. Do it this way, but it will be a bit too much work. I mean, it's too much work, but just how I would do it by hand, basically. Prediction, which is basically for x index, x value, and enumerate x. I could just do them all by one, but what is more clear? Yeah, I think that doing the whole thing in one go is more clear. So the whole thing would be the derivative of theta null is basically this one. So it is theta 0 plus t1 times x e minus y e. So this is basically t0. This is this 0 equals to 1 divided by n times the sum of this and t0 is basically that times x this, and now we have another one here, x e. So we can just basically do it. We get n is equals to ln x, then we do sum equals 0, sum equals 0, maybe some t0 equals 0, some t1 equals 0, and I do both in one go.
M.
Thank you, Karsachin. Just doing my best here. And when we have it, then we do for x value, or not even for, how was it? Where's the Python cheat sheet loops? For index in range 10. For index in range. And we do first we do we get x, no, we don't need to get it. Do it with e to make it clear. Then basically the sum t0 equals 2 but I already had the model, so I already have this actually. Fuck, I really don't need to do so much work. I don't have the cost function, but this one is the, this is wrong by the way, but it's to be, it's here, but yeah. No, this has to be wrong. Not power 2. Oh no, this is correct. But well, multiplied by sum again. And, yeah, okay, no, it's right, it's right. Just copy this basically. Just basically copy this again. And do this. This I will put here. That is basically this one, the sum t0. And the sum t1 is that times x index. And then we do t0 equals to n times sum t0, sum t1, sum t1, and return t0, t1. Now I tell AI to check the answer. Check the compute grad limitation. Is it correct? The forms of the partial derivatives are different from the wholes implemented in some typical when it's using squared error term. Yeah, that's a mistake on my part. It's using the math pow, but we don't need this. We are right. We just need this. Check it now. Oh, what happened? It died. Check it now. Check it again. I fixed it. Why is it wrong? Ah, okay. Yeah. Because if I don't do it, you're right. Let's accept it. The multiplication order. Perfect. So we have it. Relative of the cost function. Now that we have the compute gradient, I don't know how to do this. The gradient is given by the compute gradient method and scaled by a scalar and subtracted from those given data values. So we got this. And then what do we subtract? And scaled by a I think I know what it wants me to do. Oh, that's not what I wanted. You know what it wants me to do, but I'm a bit tired. But let's go. So what it wants me to do is to do t0 equals to update values equals to maybe gradient t0 opt update t1 update equals to gradient, and then we get x or y theta 0 theta 1, and then this one is basically t0 minus t update times alpha, and t1 is basically the same thing, t1 and t0 update, and then we return t0 t1 check update theta. Yeah, makes sense. Perfect. Using the compute and update theta function, we can outline the gradient algorithm. This should include complete history of the found values and the cost of additional with verbose argument can control whether further observations such as for 0 and the cost and the required iterations or achieved accuracy. God. So the initial theta 1 and 0, 0, 1 should be random. And then what if the during evaluation? No, we want the polygon one. Just like a lot. Okay, just this one is the important one. It's this one. So basically, T0 randomly in which way? What would be their range? No, don't fix it. Okay, so this two form not gonna work because I don't think this should work for Yeah, exactly. Compute grad. Where's compute grad? It is here. The value. Where is it? I don't know why it keeps saying the implementation says right and then they just like fail. Either one. But I'm confused. It's just a random number. Okay, let's see. Which other exercise I do? Mm, no, this is not multivariate. Why is it running?